In this video, we're going to learn another differentiation rule called the chain rule, and we're also going to see how to take the derivative of an implicitly defined function. Okay, so first let's look at a copy of the chain rule. Let's see what that is. Here's the first form of the chain rule. All right, so it says, let's suppose we have this function f of u of x. So that's a composite function. F is the outer function and u of x is the inner function. And the derivative of that will be the derivative of f prime of u, times the derivative of u, which we'll call u prime of x. Okay, let's look at an example. Let's suppose that h of x, just a simple a simple function, 5x squared plus 7 cubed. So we'll write h of x as a composite function, f of u of x. And in this case, f of u, f is the outer function, f of u is equal to u cubed, just the cubing function, parentheses cube. And here's the inner function, 5x squared plus 7, so that would be u of x. All right, so let's just see what this chain rule tells us to do. It tells us how to differentiate this, how to differentiate h of x. And basically it says just take the derivative of this is of the outer function, that's the parentheses cubed function, times the derivative of the inner function, that's the 5x squared plus 7. So sometimes we read this as derivative of outer times derivative of inner. All right, so let's do that. So h prime of x is equal to, okay, now the derivative of u cubed, we would just bring down the 3. But we're not going to write the u, we're just going to write a set of blank parentheses. Bring down the 3, just do the power rule, okay, and subtract 1 from the exponent. Instead of writing u here, I'm going to fill in with what u is equal to. So that's the f prime of u part. And then u prime of x, we're going to just take the derivative of this, and that's 10x. So we'll multiply by 10x. So that's how we do the derivative of this composite following the chain rule. All right. Now we're going to look at the second form of the chain rule using the same example, taking the derivative of this same h of x. Okay, here's the second form of the chain rule where we're trying to find dy dx. And we're assuming that y is a function of u and u is a function of x. So first we do dy du, and then we do du dx. All right, so I said I'm going to rewrite this function h of x. Here was h of x. And here we have the function written a different way. Here we say that y is equal to u cubed, but u is equal to 5x squared plus 7. So if we substitute for u 5x squared plus 7, we get h of x. All right. In other words, if we put these together, we have y is equal to 5x squared plus 7 cubed, what we called h of x before. All right, now we're going to follow this chain rule to take the derivative. So we'll say dy dx is equal to dy du, well, that's take the derivative of y with respect to u, so just take the derivative of u cubed, so that would be 3u squared, times du dx, okay, just take the derivative of u right here, and we'd get 10x. Now, if we write what u is equal to, u is 5x squared plus 7, just substitute that in for u, we get 5x squared plus 7 squared times 10x. All right, and this is the same result that we got previously for h prime of x, the same thing. Okay, so here's our first practice problem, and the way it's set up, the way y is written in terms of u and then u is written in terms of x, we're going to use the second form of the chain rule. So let's write that out again. So we have dy dx is equal to dy du times du dx. Now notice it's not hard to remember this because on the right hand side over here it appears as if the du's can cancel and we end up with dy dx. So symbolically it does look like we have dy dx on the left and dy dx on the right. Alright, but let's just follow this. So we have dy dx is equal to dy du, okay, right there. That would be 3u squared. And now times du dx, let's take the derivative of this, and we get 10x minus 2. And now we want to write this in terms of x, so we want to substitute back what u is equal to. Remember, here we had u is equal to 5x squared minus 2x plus 1. So we'll just substitute that back for u. Okay, so this is equal to 3, 5x squared minus 2x plus 1 squared times 10x minus 2. Alright, so that's our derivative dy dx. Now, usually we use that second chain rule formula, that dy dx is equal to dy du times du dx. We use that form only if our function is written out like this. Y equal to something with only u's in it, and then u equal to something written in terms of x. Alright, we don't have that in number 2. In number 2 we just have a function of y, and it happens to contain an inner function and an outer function. So when we see this, we'll just do the chain rule by having this phrase in mind. The phrase is the derivative of the outside times the derivative of the inside. And we have to be able to recognize the outside and the inside. Well, it's not too hard to do. Usually we have something like a set of parentheses, and when it's inside the parentheses, that would be the inside. So, or a square root maybe. So here the inside is 7x plus 2, and the outside is parentheses exponent 4. Alright, so keeping that in mind, let's do dy dx. The constant 10 just stays in front. Alright, now for the derivative of the outside, well, that would be the power rule. Bring down the 4 and subtract 1 from the exponent. When we bring down the 4, we'll multiply by the 10. So here we have 40. Keep the 7x plus 2 as is, and reduce that exponent by 1. Alright, so we did this part. That's the derivative of the outside. Now we're multiplying by the derivative of the inside, so we just multiply by the derivative of 7x plus 2, that's the inside, and the derivative of the inside is 7. In number 3, we have a power in the denominator, so this would be easier if we write y as a power. So let's rewrite this. Let's write y equal 3x plus 2 to the minus 4. Okay, that'll simplify things because we easily can take the derivative of a power. Alright, so here our inner function is 3x plus 2, and our outer function is parentheses exponent minus 4. Alright, so let's keep that phrase in mind. The derivative of the outside, we would just bring down the minus 4. Subtract 1 from the exponent, minus 4 minus 1 is minus 5. And copy the inside exactly as is. And now we multiply by the derivative of the inside, and that's just 3. In number 4, we have a function that's a product. 2x cubed is the first function, and square root 3x plus 2 is the second in the product. So here, we're going to use the product rule. But when we use the product rule, when we take the derivative of the second function, then that will involve a chain rule. All right, so let's start. Let's remember the product rule. I'll just put it up here in the corner. Derivative of a product, first times derivative of second plus derivative of first times second. Okay, so let's start with f first, so that would be 2x cubed. Times derivative of second. Okay, right here. Now we're going to use the chain rule. Let's just rewrite this for a second. In order to differentiate 3x plus 2, it would be nice to write that square root as the power 1/2 so that we can use our power rule. Okay, so now we're differentiating 3x plus 2 to the power 1/2. So we're going to do a little chain rule here, derivative of outside times derivative of inside. So the outside would just be power rule, bring down the 1/2. Copy the inside over exactly as is. And then we have 1/2 minus 2/2. 1/2 minus 1, 1/2 minus 2/2. So we have a minus 1/2 over here. And we're not done with the chain rule yet. Now we have to multiply by the derivative of the inside, so that would be 3. Okay, so now so far we did fg prime. That's f, and all this is g prime. Plus f prime, okay, here's f, okay, f prime is easy, that's just 6x squared. Okay, f prime times g. Now just copy this over. Okay, so there we are. So this was, let me just write, this was f. The second to the right of this dot, all that is g prime. Okay, this piece here, 6x squared, that's f prime. And this factor over here, that's g. All right, so that's the product rule, and right here within the product rule, we had to do a little chain rule. In the next example, we have a quotient. And in the denominator, we have a composite function, so we're going to use the chain rule when we take the derivative of this denominator. But first, let's remember the quotient rule. Let me write it over here. F over g prime. So we square that denominator, put it here, then put the denominator right here, multiply by the derivative of the numerator minus derivative of the denominator times the numerator. All right, so let's keep this in mind, and let's go and find dy dx. Okay. So first we're going to square the denominator. So that square root pops off, and in the denominator we get 3x squared plus 7. And now put the denominator right here, this denominator with the square root. Times the derivative of the numerator. Okay, so that's 2x. So far we did that. Denominator, derivative of numerator, minus derivative of denominator. Okay, that's this. So here's where the chain rule comes in. Now I'm going to imagine that, oh, let me just rewrite this. With a 1/2 here instead of a square root. Okay, so now we're doing g prime, that's the derivative of this denominator, so we're going to do derivative of outside times derivative of inside. So for the outside, just bring down the power, subtract 1 from the exponent, 1/2 minus 1 is minus 1/2. And now continue with the chain rule, we're just finding g prime. Derivative of 3x squared plus 7 is 6x. So that's all g prime, and now we have to multiply by f, the numerator, multiply by x squared plus 5, keep it in parentheses. Okay, and that's it, and we're done. So let me just label this. This was G, this was F prime. And let's see, I'll just put a little dot in here. And to the left of the dot, that's all G prime. And that's F over there. And right here in the denominator, we have G squared, the denominator squared. Okay, number 6 is a little tricky, so let's follow this carefully. We actually have two chain rules here. Okay, so let's keep in mind the phrase derivative of outside times derivative of inside, and we have to stay focused on what step we're up to. All right, so let's just write down dy dx. And now I'm thinking of the outer function is brackets exponent 10. And the inner function is this, what I'm underlining, everything within the bracket. Now the inner function contains another composite, but for now I'm only thinking of two functions, one outer, bracket exponent 10, and that inner, one inner. Okay, let's do derivative of outer, so that would be bring down the 10 and subtract 1 from the exponent and copy over what we underlined exactly as is. All right, so that's derivative of outer multiplied by derivative of inner. Okay, so let's put that here for the derivative of the inner. So derivative of what I underlined is 2. Derivative of 2x is 2 plus, and here to take the derivative of the second term, we have to do a little chain rule over here. So we're going to bring down the 3. Change the exponent to 2, and then take the derivative of this inside function here, 2x. Okay, so that's the derivative of what was underlined, the underlined function. In number 7, we're asked to find where dy dx is equal to 0. All right, so y has an outer function that is this cubed root, and the inner function is what I'm underlining. Let's rewrite y using exponent 1/3 instead of cubed root so that it's easier to use the power rule. Okay, dy dx. Derivative of the outer, bring down the 1/3. And here we do 1/3 minus 3/3, so that's minus 2/3 when we subtract 1 from the exponent. So that's the derivative of the outer times derivative of the inner, derivative of this. That would be 2x minus 7. And now we want to know, when is this equal to 0? So that's what we have to solve this equation. When is this equal to 0? Well, it's best to write this as a fraction. This negative exponent will bring that down. So we have, in the numerator, we have the 2x minus 7, and in the denominator we have this 3, and then we have x squared minus 7x plus 12 to the 2/3. And we want to know, when is this equal to 0? Okay, so a fraction is 0 when the numerator is 0. So all we have to do is take that numerator, set it equal to 0. So we just write 2x minus 7 equals 0. All right, so we have 2x is equal to 7. And x is equal to 7 over 2. And that's a valid answer as long as it doesn't make the denominator 0, as long as it's not a 0 of the denominator, which it isn't. Okay, so we're fine. That's the place, the x value, where dy dx is equal to 0.